Today I'm going to be making 1,4-dioxane, a very useful solvent with special properties which I will use in some of my projects. I'm going to be making it from antifreeze, which is pretty much mostly ethylene glycol and sulfuric acid. I'm using clean, high-quality sulfuric acid, but you can definitely use dirty drain cleaner acid as the reaction proceeds perfectly fine as well. Begin by adding 400 milliliters of antifreeze into a round bottom flask. Make sure the antifreeze is not pre-diluted and it's the concentrated version. Otherwise, there's a lot of water in it. I then slowly add 50 milliliters of concentrated sulfuric acid. Make sure to have strong stirring during this step. The addition of sulfuric acid generates quite a bit of heat and it might cause some stuff to boil. Once all the sulfuric acid was added, I assembled this setup. It's basically just a simple distillation setup, but with a 2-neck flask and an addition funnel. In the addition funnel, I fill it up with another 500 milliliters of antifreeze. I then heat the solution to 150 degrees Celsius. It's important to keep the mixture below 180 degrees Celsius since the dioxane that is formed auto-ignites above 180 C, if there's any oxygen present. The risk of autoignition above 180 C is still pretty low since most of the dioxane vapors push away all the oxygen, but there's still a bit of a risk, so it's important to keep it below 180 C. As the mixture heats up, the sulfuric acid dehydrates the ethylene glycol to form 1,4-dioxane. The reaction also produces water, and this is distilled off along with the dioxane. Here's a slightly more in-depth version of the process. First, the sulfuric acid protonates one hydroxyl group of the ethylene glycol. This causes it to pop off as water and leave behind a carbocation-like intermediate. This intermediate is attacked by one other hydroxyl group of another ethylene glycol molecule. This forms diethylene glycol, which is dehydrated by the sulfuric acid, causing it to cyclize and form 1,4-dioxane, and kicking off water as a byproduct. The sulfuric acid is regenerated and it never gets diluted since the water is continuously boiled off. This means that in theory we can add as much ethylene glycol as we want. However, it's good to use a 10-to-1 ratio of ethylene glycol to sulfuric acid. Quick side note, you may notice that my antifreeze is neon yellow in color. Some antifreezes and most antifreezes are actually blue, and I guess my antifreeze is just different, but all antifreezes work no matter the color. The mixture eventually heats up, and once it reaches 150 degrees, it's boiling vigorously. The bubbles are 1,4-dioxane. Ethylene glycol and sulfuric acid have much higher boiling points, so they remain in the flask and they react. All the water and dioxane formed, however, is distilled off and is collecting in the collection flask. Once I start seeing drops in the collection flask, I slowly open the valve of the addition funnel. I adjust the rate of addition to match the rate of distillation. As more antifreeze is dripped in, it also reacts with the sulfuric acid in the same process as before and boils off as dioxane. Using the addition funnel and this setup over here instead of just mixing all the antifreeze at once helps us use less sulfuric acid and a smaller setup. The distillate coming over is mostly yellow, with a small amount of orange stuff. If you use pure ethylene glycol, the distillate should be completely clear, but since I used contaminated antifreeze, there's a bunch of additives and side products, which can have colors. It's fine anyways, as we're going to purify our dioxane later. I made the mistake of being impatient and dripping the extra antifreeze a bit too fast, which caused a bunch of stuff to boil off, and it all foamed up and boiled into my distillate, giving it a dark brown color. It's a bit sad, but it's still okay, as we're still going to purify it. Eventually the flask got a little bit too full, so I swapped it out. I collected 800 ml of distillate in total before turning off the heating mantle. You can see that the stuff in the new flask is a lot clearer than the brown stuff in the old flask. This is because I was patient this time and I added the antifreeze slowly, so it didn't boil over. It's now time to purify the dioxane, and I put it all back into a large round bottom flask. I combined both the dirty and clear dioxane since we're going to purify them both at the same time. And then carefully add 10 more ml of concentrated sulfuric acid. We're going to redistill the dioxane with some extra sulfuric acid present. The point of this is to hydrolyze some impurities. You might think that they had been hydrolyzed earlier because we had a bunch of sulfuric acid present, but that's not the case. This is because the water was constantly being boiled off as soon as it was formed, so it didn't have enough time to work together with the sulfuric acid and hydrolyze the impurities. This time here, in all of our dioxane distillate, there's a bunch of water present, so the sulfuric acid can work together with the water and hydrolyze the impurities. Once all the acid was added, I assembled a distillation setup and distilled off the dioxane. Dioxane and water form an azeotrope which boils at 87 degrees Celsius. Pure dioxane boils at 101 degrees Celsius, but there's so much water present that all the dioxane combines with the water and it all comes over as the azeotrope. So I collect the fraction boiling between 85 and 95 degrees Celsius. I know it's a pretty broad boiling range, but I wanted to make sure I got all the dioxane over since I'm going to do some more steps to purify it afterwards. Some side products come over below 85 degrees Celsius. This fraction consists mostly of acetaldehyde, which comes from the dehydration of ethylene glycol. This fraction may also consist of some 2-methyl-1,3-dioxylane, which comes from the reaction of ethylene glycol with the acetaldehyde. Most of the methyl dioxylane, however, is hydrolyzed by the sulfuric acid. Anyways, when the temperature reaches 85 C, I swap out the flask and collect the dioxane azeotrope. I ended up collecting exactly 500 milliliters of the dioxane water azeotrope. As the temperature reaches 95 C, I turn off the heating and let everything cool down. I now have some very wet dioxane. Quick side note, dioxane and water are completely miscible, which means that you cannot do purification steps like bicarbonate washes or brine washing since all the water is just going to mix with the dioxane, and you won't form layers. Anyways, once everything cooled down, I take off the flask and I add a stir bar and place it on a stir plate. To get rid of the water, I add a bunch of potassium hydroxide. I began by adding 10 grams of the KOH, and I added an extra 10 grams every few minutes, with a total of 80 grams. Potassium hydroxide is a great drying agent for ethers like dioxane, and it also polymerizes most of the impurities. You can see this as the solution is turning orange. As I add more KOH, it gets more and more orange, and a separate layer forms on the bottom. The lower layer is all the water, and it separates from the dioxane because it's saturated with potassium hydroxide. You can see the dioxane got very dark, and this is because all the potassium hydroxide is destroying a bunch of these additives that were in the antifreeze. I let it stir overnight and then decant the upper dioxane layer into a clean flask. There is still a small amount of dioxane floating on the water layer, so I add it all to a separatory funnel to get all the dioxane from the water layer. I drain off all the lower water layer, and I put the dioxane layer back into the flask where I decanted all the dioxane earlier. To further dry it, I add another 20 grams of potassium hydroxide. This causes the dioxane to become even darker, which means that the potassium hydroxide I added polymerized some more impurities. I then distill the dioxane, and this time collecting the fraction boiling between 99 and 103 degrees. This is a 4 degrees Celsius boiling range, so the dioxane coming over should be pretty pure. I also filled the vacuum adapter with calcium chloride just to make sure everything was fully dry. I discard everything below 99 C. I'm now collecting the pure dioxane, and I collect everything until the temperature reaches 103 degrees. I had to swap flasks because I ended up breaking my conical flask, don't ask me why. Thankfully, I didn't lose any of my dioxane. Once the distillation was over, I got it all into a dark labeled bottle. I included some molecular sieves to keep everything dry, and a small amount of BHT, which is a stabilizer and prevents the formation of peroxides. Dioxane, like all ethers, over time and with exposure to light and oxygen, tends to form explosive organic peroxides, which are quite dangerous. BHT prevents this. To fully block out light, I cover the bottle in aluminum foil. The final yield of dioxane was 372 mils, which is a 54% yield. If you have any questions, feel free to write them down in the comments and I'll reply.